Hello everyone, it's Mr. Wolf here, and in this video I am going to be reviewing problem number 1 for the LT5a practice. So if we look here, a 50 kilogram skier is already traveling down with some speed at the top of the hill. So that looks like it's my initial condition right here. So by the way, I always like to kind of draw out a picture here. So let's actually do that. Here's our hill, and I'm going to start to label everything because there's a lot of different variables here. So here's my skier. Doesn't have to be the perfect drawing. And it looks like their mass, kilograms is mass, so their mass is 50 kilograms. It's traveling with some speed, so we know that there's an initial velocity. We don't know what it is yet. At top of the hill, and the hill is 8 meters tall. All right, so that's the height, by the way. So I'm going to say h equals 8 meters because that's going to be different than the distance, by the way. All right, so as the skier skis down the hill for a distance, so it looks like that distance is equal to 10 meters. So that's kind of like our hypotenuse, right? And the height here is our 8 meters. Very steep hill. They experience a force of friction of 100 newtons. So I'm just going to maybe label here force is 100 newtons. And they reach the bottom of the hill with a speed of 120 meters per second. So pretty dang fast. So I'm going to say final velocity at the bottom of the hill is 120 meters per second. All right, then, and let's see, it's at the bottom of the hill. So if that's the case, I'm going to say that my height is equal to 0 meters because I'm at the very bottom of the ground. The initial location is at the top of the hill. The final location is at the bottom of the hill. Complete the LO diagram and equations, then calculate the velocity of the skier at the bottom of the hill. Okay, so that's what we're looking for at the end of the day because we just listed a bunch of different things. What are we trying to solve for? It's this initial velocity. So I'm towards the side going to put V naught equals question mark. Okay. And then the next thing we always want to do is just write down all our known variables, which we've done thus far, right? Height, mass, distance, force, final velocity, final height. But in order to make our equation next, to choose the right equation, we have to build that equation. And how we're going to build the equation is with the LOL diagram. So at the top of the hill, it says that what we always want to ask, is there velocity to determine if there's K, and is there height to determine UG, potential energy? Is there velocity? It says they're already traveling with some speed, and that's what we're trying to calculate. So yeah, there's going to be kinetic energy. All right. And they're at the top of the hill, so that is their height? Yes, 8 meters tall, so we're going to draw some UG. All right. So again, it doesn't matter, like you could have drawn 4 blocks for each of these, 2 blocks for each of these, as long as you have some K and some UG, which I have right here. I decided 2 and 3. And again, that's just my decision. But if that's the case, I know that I have a total of 5 energy blocks here. Now then, if for this section, I want to ask myself, is there an outside force? All right, that could either put energy or take energy away from my system. And in this case, yeah, there is. They experience a force of friction of 100 newtons. And we kind of know when you have that friction that's going to take energy out of our system. It's really going to slow an object down. So I'm going to have an arrow leave here. And maybe, I don't know, I take out 2 energy blocks. Again, I just decided to make up how many I'm taking out. So 2 energy blocks. And remember, any energy that enters or leaves the system, that's called work. Right? And then, well, what was that caused by? Caused by, again, it was that force of friction, right? So force of friction. All right, so I had 5 total minus 2 energy blocks, which means I need to have 3 total blocks here. So I'm going to ask, as always, my questions. Is there velocity? Is there height? And they say that they're at the bottom of the hill, so my height is 0 meters, so no UG. Right? Intuitively, the skier is definitely moving towards the bottom of the hill, and we know that all these blocks have to be in kinetic energy because we know there's no UG. So I'm going to draw 3 energy blocks for kinetic energy. So then again, my energy is conserved. Total energy is before still the same as the total energy afterwards. All right, just some energy left our system. So 5 here and then 5 here, so we're good. So now we're going to use these LOLs to draw or make our equations. So for my energy types, I've got K initially, I've got UG initially, so K plus UG. Right? And then in this case, we have work, but specifically we're subtracting work. Energy is leaving our system. And at the end, that's going to be equal to all our energies in kinetic energy, so K final. So then what I could do is I could start to expand out this equation. Right? I could do 1/2 mv squared, because that's the equation for K. UG, the equation is mgh, minus force times distance. And then again, that's going to be equal to k final. So 1/2 mv squared is my equation for k. So this is my full equation. It looks complicated, but it's not too bad. A lot of it is just starting off, knowing all our known variables, and really taking the time to make a good LOL diagram. So at this point now, it's just matching our variables correctly. So for instance, 1/2, my mass in this case is 50 kilograms, so I'm going to plug 50 kilograms in. My initial velocity, well, that's again why it's so important to write this out kind of towards the side. That's what we're looking for. So initial velocity is just going to be squared. It's so easy to just see this velocity right here, this final velocity, and want to plug it in. So you want to make sure you're keeping track of all your variables initially and then also final. Again, my mass is 50 kilograms. G on Earth is always 9.8, and my height in this case is 8, minus the work, which is force times distance. My force looks like 100 newtons multiplied by my distance, which is 10. And that's going to be equal to 1/2. My mass, again, is 50 kilograms. And then my final velocity, I do know, that's 120 meters per second. And then we are going to square that value. All right, so let's do the math on this now. Because at this point, we've done all the physics. Now it's just the algebra. So 1/2 times 50, that's 25. And then my initial velocity squared. All right, plus, when we multiply these variables together right here, we're going to get 3,000, looks like, kind of cheating here and going off my key, 3,920 minus 100 times 10 would be 10 or 1,000. And then I'm going to square my 120 first, so square that first. And then once I have that number, then I'm going to multiply it by 50 and then 1/2, and I'm going to get 360,000. And then to break down the algebra a little bit more, we do 3,920 minus 1,000. That's going to give me 2,920, so still 25 velocity squared plus 2,920 is equal to 360,000. I'm going to do now, just trying to get velocity by itself, I'm going to subtract negative 2,920 from both sides, and I'm going to get 25 initial velocity squared is equal to 357,080. Then I'm going to divide 25 by both sides. So when you divide 25 by both sides, 357,080 divided by 25 is going to give me velocity squared is equal to 14,283. Now I'm going to take the square root of both sides. And my final velocity, my velocity actually, it's my initial velocity, but finally calculating my velocity, that's going to be the square root of 14,283 is going to be 119, about 0.51. It's okay if you're off by like 1 or 2 decimal points. All right, 51 meters per second is my initial velocity in this case. So I know the math here is kind of complicated, or at least there's just a lot to it, but just to kind of highlight the important parts, right here is the physics. Like making your LOLs, making your equation, and correctly matching your variables, that's the physics. That's what I care about the most in terms of assessing your knowledge. Right? Yes, it's important to have an accurate answer, but I put so much more weight on this part right here. So if you got to this section, you should feel good. You should feel like you're just about at that 3-level type of work, and then it's just working on the algebra. And remember, you guys can always ask me questions about these things as well on an assessment. All right, thanks for watching, everyone.